Professor, I have a question before we get started.
Yeah, sure. Just give me 1 second. All right, welcome back to another lecture of cloud computing. So today we are going to discuss specifically about the database services that are offered by the AWS platform. And specifically, we are going to talk about the relational database services that is offered by AWS in particular, right? So the relational database service that is offered by Amazon is known as RDS in short, which stands for Relational Database Service, right? So there are two ways in which you can run a database on AWS itself. So the first option is the basic traditional option, where you don't go for the RDS service per se. What you do is you set up an EC2 instance, and within the EC2 instance, you have the option to set up your database stack, just like you would normally do if you're working on, let's say, a local computer and things like that, right? Similar to those lines, right? So in such a situation, depending on the relational database platform that you would like to work with, you would basically have to install the database server on the EC2 instance that you have started, right? So that could be in the form of a MySQL server, that could be in the form of MariaDB, that could be in the form of Amazon's own relational database stack that is known as Aurora, or PostgreSQL, or IBM server, or Microsoft server, and things like that. So all of the options that you have available on your local computer with respect to running a relational database, the same applies to running a relational database stack on your EC2 compute engine, right? The other option is you go for database as a service, which is basically what RDS is, right? And the difference between having your own stack on the EC2 platform versus opting for the service itself of database from your cloud provider, the difference is that in terms of the setup and in terms of different options such as elasticity, management and maintenance with respect to updating the database itself, or applying patches with respect to security, or keeping in track of the security of the service itself, the cloud provider will be responsible for all those actions. Okay, that is if you opt for the database as a service on the cloud platform. Whereas if you do it in the traditional route, if you opt for the traditional route, that is if you set up your own stack on an EC2 engine, then essentially you don't get those added benefits that the cloud is providing with respect to setting up the environment, with respect to elasticity, with respect to update and maintenance of your database itself, right? So essentially, if you go for database as a service, as it is listed here on this slide, with respect to the hardware provisioning, the cloud provider will take care of that, right? So, but you just get to opt for what kind of hardware, virtual hardware will be running your database server. Because at the end of the day, you need to remember that databases are basically a server that is running on some sort of a compute engine, right? So that means you can either choose your own hardware provisioning, which comes in the form of setting up an EC2 environment, or if you go for database as a service, you do specify what specs of hardware provisioning you want. But in order to set up that environment, the cloud provider will take care of that activity for you, right? So you can, the cloud provider will provision the environment. The cloud provider then, based on your specifications that you provide, will set up the environment. It will provide any type of patching, any type of vendor updates that may be applicable with respect to the type of relational database server that you're running. And then it also takes care of backup, fault tolerance, and all those features that should be present within a database environment, right? So other than that, when you're working at least on AWS platform itself, right, there are 3 different types of instances that will be available for you to pick from when you're trying to specify the hardware provisioning environment. So remember, when we spoke about EC2 setup, right, we talked about different type of instances that you can go for, right? There is this feature when you set up that is known as instance type, right? And the one that we have been working on, which is basically specified within the free tier, is the general purpose, or the T category of instances, right? So there are many different category of instances, which are, for example, memory optimized, which are compute optimized for computationally intensive tasks and things like that. And in addition to that, some of the different instance types that apply specifically to a database server are in the form of performance optimized, or the ones which are input-output optimized, right? So if you're running a lot of, if you're running an application which requires to perform a lot of read and write operations against your database, then you would be better off probably selecting a compute engine that is optimized for IO operations, right? If you need a very high throughput, right? So if you're not doing the input-output operations in a continuous fashion or something along those lines, then you can go for performance optimized. If you need to run a lot of operations on the memory itself after bringing the data from the database, then you probably would be better off selecting for a compute engine that is memory optimized. So you get those options as well when you are provisioning your database service on AWS as such, right? So again, the options that are available are plentiful, and these are all the mainstream categories of relational databases that are available on the market. So the only difference is that Amazon, in addition to other service providers for database servers, also offers their own subset of relational database that is known as the Amazon Aurora, right? So you can think of this, you can kind of draw correlations or project these service offerings with respect to the machine images that you opt for when you're setting up your own VM environment through EC2, where you have to pick from one of the distributions of guest operating systems that are available on the Amazon AMI catalog, right? And we all saw that Amazon has its own distribution of Linux, right? Which is the AMI versions that we have been kind of working with whenever we wanted to work with Linux. But you also know that Linux has other different types of distribution of the different flavors, right? In the form of, let's say, Red Hat is there, SUSE Linux is there, and other options are also available, right? So similar to that, for other relational databases, for different categories of relational databases, you get to opt for either one of the top vendors that people generally go to, or you can go for Amazon's Aurora, which has its own benefits with respect to how much the extent of input-output operations you can run, what is going to be the cost with respect to the input-output operations and stuff like that, right? And as we had discussed in the last class towards the end very briefly, there are some use cases that are also available for you to kind of familiarize yourself with, like how it is being used. And these are some of the few of the well-known companies that kind of employ Amazon's RDS service within their system architecture, right? So if you're interested to get an understanding of how they incorporate these database as a service in their system architecture, then visiting this link and going over those use case studies is a worthwhile read, okay? So again, keep in mind, when we think of RDS, or when you are ever encountering relational database service, or sometimes they will call it as database as a service if there is no distinction between relational or non-relational databases. There is another service for non-relational specifically on AWS itself. You have to think in terms of a software stack that is being set up for you on an EC2 instance with a database server running within it, right? And that is the only purpose for which that EC2 instance will be provisioned to you. So it's in your head, when you're translating this particular service, right, it should not come in the form of like database is something entirely different from, let's say, a regular EC2 instance. That is not the case. It's basically a very special case of an EC2 instance where an EC2 instance is being prepared. And then with respect to provisioning and setup of the environment of the database, the cloud provider is basically taking care of that instead of you taking care of it. And that comes, as we discussed, with added benefits of maintenance with respect to the security of the database, with respect to making sure that the automated aspects of scaling up, the automated aspects of scaling out are taken care by the cloud provider itself, right? You get to choose the instance type, as we discussed, but depending on the type of instance you choose, that will have a proportional effect on the cost model. that will be followed in order to run your database instances, right? So if you go for something for us, like for example, we are always going to be selecting the T2 micro, right? Which is what we are offered when it comes to free instances or free tier account, right? But if you go for, let's say, memory optimized, or if you go for IO optimized, then you will be paying a little bit more in comparison to, let's say, the T2 micro or the T3 micro and things like that. Okay. There are also some restrictions when we work with a free tier account, which is in the form of the fault tolerance options or the architecture availability that we will be given when we are working with free tier. So there is a thing, and we will see that through an exercise with respect to system architecture that we call as a multi-availability zone deployment, right? So this multi-availability zone deployment option is not covered through the free tier account. So if you go through the exercise that we are going to be doing today, it will charge you like $2 or something for getting to understand how to set up the multi-availability zone deployment, okay? But this is a very important feature that you need to be familiar with when it comes to launching a database service. And more often than not, when you're working with a full stack environment, you will be working with some sort of database service in order to kind of store your data, in order to effectively manage your data, and then query your data as well. So it is very important that you all make use of that $2-3 to understand exactly how this multi-availability zone deployment works, okay, going outside of the boundaries of our free tier account, right? It also gives you the option, so it's not set in stone that once you specify a particular EC2 instance type to start your database service, then you are stuck with that, right? So there is no restrictions as that with respect to your database service, right? So at any point of time, you can choose to change the instance type, which is basically hosting your database server. So initially, you might start off with, let's say, some sort of performance optimized or memory optimized compute engine, but later on, if your functional requirements changes for your database service, then you can dynamically switch to a different instance type that is essentially hosting your database server. But you have to keep in mind that if you do choose to do that, there will be a downtime with respect to your service, because essentially AWS or the cloud platform, wherever you're working, each different cloud vendor has their own flavor of how they manage this, but the fundamental or the core concepts of how this is executed remains the same, is that if you switch from one instance type to another instance type, that is basically a migration that is going to take place, right? And when it comes to database, there will not be a pure, complete live migrations as we had previously discussed. It is something that is going to require a stoppage of querying your databases and then moving to the new compute engine, okay? There are workarounds around it with respect to the architecture, and that kind of goes back to how we set up this, what we call as this multi-availability zone deployment. But multi-AZ deployment is not just for switching between instance types. It is much more than that. It is to prevent a complete failure of your service, of your database service that is supporting your main application stack, right? So we will talk about that essentially, okay? And remember, Amazon will offer their Aurora engine, and the Aurora engine has slight benefits over the other database engines that are available. And if you choose to not go with the additional benefits that comes from choosing a database service, if you feel that there isn't much to do, so we don't have to opt specifically for a database service, and you want to, locally install your database server wherever your main compute engine is running, then you are more than free to do so. You can install that as a separate software stack by yourself within your EC2 instances, right? But what you lose for that is you don't get the automated administrative benefits with respect to the automated and the automated management services that comes with RDS as such, okay? And then what you have to keep in mind that when it comes to database as a service, in terms of elasticity or in terms of scalability, there are two different options. What we call as is vertical scaling, okay? Which is also known as scaling up. And then another one that is known as horizontal scaling, which is known as scaling out, right? So vertical scaling or scaling up is basically improving or making the resources that you're already working with more profound is not the best word for it, but it's like if you're working with, let's say here as the example, such as that you initially started off your database server on an instance which had, let's say, 2 virtual CPUs and 8 gigs of RAM. If you increase that, okay, to let's say 4 virtual CPUs and 32 gigs of RAM, then this kind of scenario where you're taking the existing resources and improving it further, okay, on the resources itself, that is known as scaling up, right? So because we are essentially increasing whatever resources that we had to something that is better than the previous resources, right? So that is what we mean by vertical scaling, is because we are taking that same resource and we are going up the ladder in terms of improving what we are working with, right? The other option that we have is known as scaling out, that is to expand on a horizontal scale. And what that means is that you're not increasing the specs of the infrastructure that you are working with, but you are basically adding more infrastructure to it, okay? So essentially what this essentially means is that, let's say if you have one database server, right, and then you create 4 or 5 replicas of that server, then that is known as scaling out. Because at this point of time, you started off with a single server, and then you added 3 more, for example. That essentially helps with disaster recovery. It also helps with the latency of how your database is being queried, depending on how you set up that infrastructure. So that is known as scaling out. So if we kind of compare this to a very simple example, so instead of saying, if you want to scale up, let's say you have a local computer, okay, and the local computer, let's say, had 8 gigs of RAM, and then you bought another 16 gigs of RAM slot, and then you kind of added that RAM slot, added that RAM card to the slot that was available. So that is an example of scaling up. You still have that single machine, but then whatever computing resources were there, you are increasing those computing resources further, right? But if you have an 8 gigs RAM machine, right, with and other specs, whatever that specs might be, and you buy 3 more computers and then kind of put it there in the network of wherever your local computer was previously running, that is known as scaling out or horizontal scaling. Okay, so these are the 2 different types of scaling options that are available in the database service as well. And if it is available in the database service, essentially this is also applicable to services such as EC2 as well, right? Because if you think about it, you can take this services or the examples that we have here, and you can kind of replicate that kind of behavior in terms of system architecture if you're just solely working with something like EC2 as well, right? And another thing to note is that when we were dealing only with EC2 instances, the instance type had its own encoding and then the flavor, right? So it was something along the lines of either, let's say, T2 micro, T3.micro. Here you can see there's an example, M4.large, M4.2x large. But when it comes to working with database as a service, this instance type notation has a prefix that is added to it, which is db dot, and then everything else remains the same. This kind of signifies the fact that the instance that is being provisioned is not a plain old VM environment or an EC2 environment, but it is a EC2 environment on top of which a database server or a database engine will be provisioned. Okay, so that is something to keep in mind, or a few quick features that we have, right? So let us look into, so everybody understands, I believe, scaling up is kind of pretty straightforward. Whatever instance has been initially provisioned to you, you just increase the specs of that particular instance itself, that instance and that instance only, right? So that is known as scaling up or vertical scaling. What is interesting is to understand the concept of scaling out or horizontal scaling and how it kind of plays a role with respect to fault tolerance as well as disaster recovery, right? So if we look at this architecture, this kind of sums up the extent of the architecture that you can build, keeping into account the scaling out feature for your database as a service on the AWS platform, right? So we start off with the very, usual suspects. That is, you have a region. Within that region, you have created a VPC, right? That VPC may or may not span across multiple subnets in a way of saying that are availability zones. So here in this example, we have a VPC that spans across two different availability zones or two different subnets. Whether they are public, whether they are private, we are not concerned yet about those factors, okay? Public-private is going to have an impact with respect to whether you can reach out to those particular instances that are running within the particular subnet, right? So if it is private, and if you want to set up a direct communication, you have to set it up as an endpoint that we had discussed before, or you need to reroute the traffic of the private IPs through the VPC router into an instance that is sitting within a public subnet. And if all of them are public, then there is no problem in any way, because all of the instances or all of the compute engines that are running within those subnets has basically a public DNS/public IP that is associated with it. So we don't have to worry about it at all, right? So every time you have to remember an EC2 instance is always deployed within a subnet. So by extension, if you're saying that a database service is basically an EC2 instance on which the database server will be installed for you by the cloud provider, then essentially by extension of that logic, a database server or a database instance will also be deployed to a particular subnet, right? Or to a particular availability zone. So that is the first thing that you have to remember with respect to a system architecture working with databases, right? The very primary database instance that will be running, okay, is known as an RDS master. All right. So this is known as the live version or the live instance of your database server, or the RDS master in short is what we call it. And this is going to be the instance which will primarily be responsible for receiving all read and write queries from wherever it is interacting. So it might be interacting with an EC2 instance that may be present within this architecture, or as long as this is present within a public subnet, then it can also interact with other local computers which might be sitting outside this VPC network boundary. It could be your own local computer. You could be writing your program on a local machine to test out how it performs in a developer's environment, but you are interacting with this particular RDS master. So this RDS master, just like any database server, okay, if you all have worked with let's say a full stack development, you would know for a fact that there are three different things that is required to integrate a program or an interface with a database server, right? So first and foremost, you need the URL or the DNS wherever that database server is running. You need the username of the user who is interacting. So it could be the root user for the database, or it could be some user that the root user has created. Whatever be the case, there is a username, and then there is a password that is associated with it. And in addition to that, if you want to go a little bit, a few more steps further, then you might also kind of argue that, hey, we need the database name itself, and then we might need the table name and stuff like that. But that goes more into the programming side of it and not the networking side per se, so to speak, right? We can still establish connection with the URI, username and password. And then, of course, we need the database name and the table name and stuff like that to run queries and things like those things, right? So the RDS master is going to be the node or the instance that is going to be receiving all the read and write queries to begin with, okay? So now if you want to use scaling out options, what you're going to be doing is you're going to be taking the RDS master and you're going to be creating what we call as, or what AWS calls as the read replica of the RDS option, okay? So this way, what happens is that you increase the performance of your entire database service by adding more instances that can receive read queries, okay? Because the amount, depending on the functionality, and typically the amount of read queries that are executed are much more than the amount of write queries that are typically executed, right? And of course, conditions do apply. It is not a generically or a universally true statement, right? But in most cases, you're going to see applications that are being built wherein read queries are going to be much more frequent compared to write queries. So when you're scaling out, there are not two different options, but the way it happens is that you create a read replica of the RDS master, and that is known as the RDS read replica. Those read replicas will only be responsible for handling read queries. And the replication of the master node takes place in an asynchronous fashion. Okay, so that means the master node does not get locked out when the replication process is on its way. All right. Of course, this kind of introduces a notion of soft integrity for the two different instances that is going to be present there. But if you're not using the ACID properties of transactions, if you're using the base properties of transactions, and this is something that is from advanced transaction database concepts, then there is no problem. But here in this particular architecture itself, there will be no problem as such with respect to locking out the master in order to complete the replication process, is because given the nature of the architecture, we are going to restrict the write operations only to the master, right? So that means any kind of write operations which are actually going to inject integrity problems for the state of our database, we are kind of limiting those situations that can lead to those problems, right? So essentially the master is responsible for just the read and write operations. And then the RDS replica is specifically responsible for read operations, right? So now the fun part is you can create multiple replicas and you can post it across different zones, right? Depending on how you want to scale out and how you want to reduce the load of read queries on the master. Okay, so that way, if somebody is writing to the same, let's say, table, okay, we don't have to log the table in the master, because we can reroute the request, the read request that may arrive at the same time when the master is updating a given table, a given record of that particular table to its read replica. So that way, we can service the user whose write request is being performed, and we can still keep on receiving read requests at that time. If there is the same write request on the same resource, then it goes back to what kind of transaction philosophy that you're using in order to implement your relational database, whether you're using ACID properties or whether you're using base properties. That is going to dictate whether this particular node will be completely locked out or not, right? Then with respect to, and this is purely with respect to performance, right? So this kind of setup of creating what is known as a read replica is completely helping the performance side of our application, right? In terms of the architecture. Then there is another aspect with respect to the fault tolerance or the database recovery side of a system architecture, right? So what we do in that situation is we purely, right, we exclusively, we take the replica that needs to be created of the master and we deploy it in a different availability zone, right? So this architectural setup is known as multi-availability zone deployment of your database service, right? Read replicas you can keep in the same subnet as that of the master node, but when you are setting up a scaling out policy, okay, which requires the replica to be present in a different availability zone, then the architectural aspect that you're addressing there is basically fault tolerance or disaster recovery, right? So what happens here is that if your entire subnet fails in a hypothetical scenario, this is going to be very, very, very less likely in a practical standpoint, but you don't do it, right? Because even in that 0.001% where it might fail, that is a very bad situation to be in if your backup is also in the same subnet as that of your master, right? It's the same policy as saying that, hey, my computer is never going to fail, so I will create a backup on my local machine of my original files again. That is not the policy that you should follow when it comes to disaster recovery, right? So the same policy applies here. Is what we do is we take the master, we create a replica of it, and that is known as the standby node. Okay, so all of these have their own terminology in order for us to kind of distinguish between what is their functionality, what is their purpose. So the first one is known as master, which is always going to be live. And then when we create a replica for disaster recovery purposes or fault tolerance purposes, we call it an RDS standby. Okay, so this standby, when this replica is created, in contrast to creating a replica for the purpose of performance, is done through synchronous replication. Okay, so that means anytime this master gets new data, this replica gets updated immediately, right, before writing next options and stuff like that. So you can think of this in terms of a continuous stream, that anytime the master gets updated, the replica needs to be updated immediately. Okay, and I hope everybody understands that. That is kind of, intuitive, because the whole purpose of this replica is to support disaster recovery, that in the case that the master fails, this needs to take over. So the whole idea is here that in the situation that this master fails, let's say either through the subnet failing or something happens to the router and then the master is not reachable for some reason, there's some conflict with the address resolution protocol and you cannot ping the domain here itself. That's not the best example, and I will tell you why. The reason why the DNS failing is not the best example is because you will get a different DNS or IP for the read replica, which is there for performance purposes, which is different from the master. But when you create a replica, which is the standby replica, you don't get a DNS for it. Okay, you just get one single DNS, which is for the master. And in the event the master fails, then the DNS for the master is basically given to the standby node, essentially, right? So that way you don't change the URL and your applications don't break. You don't have to go into a code and you don't have to change the dot environment variables for your database connectivity because there was a failover that happened within your cloud architecture with respect to database service, right? So in any other instances, for this instance crashing, for the subnet going down and stuff like that, then in such an event, a failover strategy is basically invoked. And then essentially this master is taken out of commission and the standby node is made the new master. And then an address resolution protocol is invoked. And then everything within the network is basically told or advertised that the new destination for the address that you were pinging before is now on this particular instances, right? So this is the architecture that you have to be familiar with, okay? And then the EC2 application, which is your primary processing stack, can be present in any subnet. It doesn't have to be specifically present in the subnet where the master is running. It could be present in other subnets. The only thing that you have to keep in mind that preferably you would want to keep it within the same region at least, okay? But remember that you do also have the options to ping these databases in terms of processing from outside the VPC network boundaries as well. So there is no restriction with respect to where you want to place the processing stack that will be interacting with your database server or your backend server, if you would like to call it that way, if you're working with this full stack development, okay? So these are the things that you have to keep in mind. These are the different features that is associated with the database as a service offering on AWS itself. Be aware of this new policy that is known as scaling out. Scaling out can be with respect to improving performance in the form of creating what is known as the read replica. Scaling out can also be in the form of disaster recovery, which is in the form of multi-availability zone deployment and creating a standby node of the master, which is always going to be live, right? So these are some of the basic features that we have in mind. So we are going to follow the 3 exercises that we have today for Amazon RDS, okay? And it will take some time every time because, entire database server will be initialized, but we are not going to push and pull data from it. I'm going to show you the networking aspects of working with these databases through these 3 exercises. And you should follow the steps that is written in these slides and follow along with me as well. Instead of just listening to it, it will also kind of help you understand the interface and then setting up these services. And the final exercise that we are going to be doing is to basically set up a full stack environment through the help of WordPress. Okay, so WordPress is basically written using PHP. So I'm going to show you how to launch a WordPress environment. Well, there's nothing to show there. It's just a bunch of commands. But so we will execute the software stack for a WordPress environment, which will then be connected to the database server that is running on a different instance, right? So if you understand that, essentially what you can do is you can connect any kind of application that you're working with to this database service that can then be ran on your EC2 platform itself, okay, or AWS platform itself. So please feel free to follow the steps that is given in the exercises, or you can follow along with what we are doing on the screens, which can be seen through the screen share itself, okay? So first and foremost, we need to move to the RDS service. Remember, RDS is the relational database service. And then the one that you see right below here is DynamoDB, is the NoSQL service for AWS platforms, okay? There are many different options for NoSQL as well. You have MongoDB. The cloud service for MongoDB, which is a NoSQL service, is known as MongoDB Atlas. That if you are very familiar with MongoDB, then probably you can go and set up your NoSQL environment using MongoDB's cloud platform as well, right? So that is a very dedicated environment just for supporting database activities with respect to a NoSQL schema, okay? But if you want to stick with Amazon and have everything integrated or consolidated within Amazon, then you work with DynamoDB essentially, right? So we will talk about that right after this. So we will go to RDS, and the region I'm currently in is Ohio. That's the region we will stick with. And then anytime you want to go to something else, you know, some other services, it will mostly be the global environment. But if you feel kind of adventurous, then you can try going to other regions and you can try things out. But essentially, the whole core concept is going to be more or less similar. Okay. So again, as identified in the slides, the summary of the exercises that we are going to be performing today is to first of all understand how to run a basic RDS service on Amazon. Okay. The basics of basics to launch just a database server. Okay. Then we are going to learn this architecture essentially. Okay. So first of all, we are going to learn about how to create the read replica. That is the technical term that we are going to refer to it, but you need to translate in your head whenever you listen to something called read replica being set up. Then we are essentially scaling out with respect to performance. And then when we are going to create a standby node of the master, then in your head, the translation should be, okay, scaling out multi-AZ deployment for disaster recovery, right? So that will be the second and third goal. And then finally, we are going to kind of connect the database instance that is running to a full stack server, okay, which will be developed using WordPress/PHP, okay? And any technology that you use in order to develop these sort of applications, the connectivity policy will differ a little bit, but the base features or the base fields that is required to be specified, at least from the database side of it, that kind of remains the same, right? So this is the goal or the summary of the 3 different exercises that we are going to be performing today, all right? So when we come to RDS, okay, you can kind of go through the different widgets that talks about the different services that are available on this particular infrastructure. But again, if this is too much clutter for you, at least for first-time users, always focus on what is happening with the left vertical menu, okay? For any kind of dashboard that we go to, it is always better to look at this left vertical menu that kind of simplifies the different types of services that is going to be provided by that particular service itself, right? So similarly, if we go back here for a second, okay, and if I open EC2 here, notice the fact that if I go to EC2, there's a lot that is going on here. If it becomes unclear as to like, oh, how should I navigate myself in this particular portal, forget about what is happening here on the center canvas and focus on what is happening here on the left vertical menu. If you go through these options and intuitively just look at the options that are given here, you can understand what is happening within this particular service, right? Or what offerings are given for this particular service. And then what happens is that if anything is not clear, you can just visit these individual options and you can try to kind of understand or create a roadmap of the different offerings of this particular service within your own nodes, so to speak, right? So similar to that, what we are looking at when we are looking at the RDS service itself is basically what are our different database that is running. So if we go here, we can avoid the entirety of the dashboard, or we can go to that same page from this particular widget that is available in the main dashboard page, right? Another thing that comes here is the fact that just as you can create backups of your VM, just as you can create backups of your volumes and file systems that is associated with your VMs, and then those backups in the form of snapshots are stored inside an S3 bucket, which is deployed to a region, the same applies to your databases as well. So in a manner of speaking, if you're creating a backup of your database, that backup after the actual database is destroyed, the snapshot is stored inside S3. So if you're getting the drift at this point of time, whenever you're working with backups, it is through snapshots, and the snapshot, the default location where it is going to be saved is an S3 bucket. So S3 bucket is like this universal purpose storage location for anything that you want to save within AWS, right? Always keep that in mind. So you can either restore if you already have a database where you have created the schema, you have created the relations, the attributes and stuff like that, primary key, foreign keys, everything is set up, right? So if that schema is there and you want to restore the database from that schema, then you can put it in an S3 bucket. And then when you come to this service, you can essentially restore a database. You don't restore it because you don't have the data per se, but essentially you can create a database from an existing schema that will be set up for you, right? So the step for that is an additional step, is that basically what you do is you create an S3 bucket in the same region, which is here in this particular case is going to be Ohio. You're going to drop your schema there. Maybe if you want, you can put one record per table that you have, just create some dummy data, put it here, right? And then you can run the database from that schema there, and you can create a database, or you can create a fresh database because it really doesn't take that many steps per se, right? So if you don't want to use the widget, again, the first option is the databases, and then it will kind of create all of these different options. They are now offering what they call a blue and green deployment, which kind of reduces the downtime whenever an upgrade is performed and stuff like that. So these are some additional quirky features that is available. Okay. In terms of launching a particular database, it is quite similar to EC2, but it has its own additional fields or attributes that kind of identifies it because of the database stack that will be launched on top of the compute engine that will be supporting it, right? So you will have specify a name, what kind of role, what kind of engine it is running. Engine in the sense of, is it MySQL, is it MariaDB, is it Aurora and stuff like that, where it is deployed, in which availability zone it is deployed. Because remember, when the first time you're going to launch any kind of database service, it is not about your read replica or your standby. It is basically about your RDS master, and your RDS master will be deployed in some subnet, right? So that is the requirement. So that is basically what this availability zone part is coming. How much size have you kind of assigned to it, right? Which is the storage that you have assigned to it. Just like EC2 instances, it will be some instance. So it will also have a status, right? Actions will be associated with it. CPU usage, what it is doing, is it available, is it updating, is it locked out? So those are the current activity. When the maintenance will be performed, which virtual private cloud does it belong to, and whether it has a multi-availability zone deployment that is specified to it or not, okay? So that is the first option. Then you have the query editor. As the name suggests, query editor is basically where you can write the queries and run it against the database that you are working with, right? So this is basically the browser option of writing your database scripts and then querying your database against those scripts that you have written. So intuitively, since we do not have any kind of database right now, we cannot work with the query editor because you cannot query something that does not exist to begin with, right? Coming to this performance insight, as it suggests, is like how your database is performing. There is nothing more to explain here. There will be different performance metrics in order to kind of keep a track of how your database is doing. Snapshot, just as we had snapshots here for our Elastic Block Store, is to basically create a replica of your database itself, right? So just like in snapshots here in EC2 services, which can be created for the entire VM or the data that is associated to the volumes that is connected to our VMs, you get to create the snapshots of your entire database, right, with the data itself, and that will be stored into Amazon. So when you create a snapshot, and if you want to put it into Amazon S3, then essentially you go to exports in Amazon S3 and stuff like that. If you want to kind of take that snapshot from this particular platform or this particular portal and then dump it to an S3 bucket of your own choosing, right? If you have created an S3 bucket like we discussed before, right? Automated backups is with respect to when you want to perform the backup. There are two options that will be given to you when it comes to backup is a periodic maintenance, right? So sometimes from different services, even from Oakland at time to time, it tells you that Moodle will not be available between these hours. And it's pretty late at night when regular folks are sleeping, right? So that is basically directly tied up to what is happening behind the scenes for these kind of activities, is that you get to specify based on your understanding of your customer base of what will be a good time to perform database maintenance or perform any kind of batch processing activities that will lock out the entire database and activities along those lines, right? So you can either choose to do that, or if it is something that is happening which is not a client-facing database for whatever reason, then you can choose to kind of apply your backups, your upgrades, your patches right now, right? You can choose that option manually. You can override the process. But essentially, remember that whenever you're going to update or patch your databases or perform any kind of very large batch processing activity against your databases, which involves all the tables and a bunch of write operations, then there is going to be a downtime. So be aware of that situation, okay? All right, so let's go ahead and start off with the first exercise. So we are going to just go to this database option here from the left of our menu, and then we are just going to hit create databases, okay? So the first page, the few options that we have to do is some of the same steps that we took when we worked with our environment in EC2, but with some added features of the databases, okay? The first main thing that you have to pay attention to is that you get two different options. You can either choose to go with what they call as standard create, or you can go with what is known as easy create, right? So it's the same as just like installing any software on your computer, where they say that, hey, do you want to install with the recommended options that we are going to provide you, or do you want to configure each and every step for the creation, right? So essentially, if you go with easy create, then you are essentially using the best practice configuration options that AWS is going to provide you. Or you can choose standard create if you're paranoid just like me and you want to make sure that every setup option is according to your requirements, and whether or not it's best practice, you will come back to that again later, right? So we will go with standard create option, okay, because that will also allow us, for the purpose of this exercise or this demo, to understand what are the different features that we have to pay attention to. All right, so the next thing is what type of database engine that you're going to be executing. So they added one more now. Previously, it was just Aurora. Right now we have an option for MySQL compatibility of Amazon Aurora, or if it is an Amazon Aura, which has a PostgreSQL compatibility. And other than that, we also have MariaDB options, Microsoft SQL Server, Oracle DB, PostgreSQL, and MySQL. So we're going to use MySQL, okay, because that is something that I use for demo purposes most of the time. If you're familiar with other database services, you may very well go ahead and set them up. There is no problem, because this exercise is mostly about networking and not the syntaxes of the query language that we will use against these databases, okay? Essentially, that is what is going to happen, okay? And then, of course, some of these DB engines have their own limitations, restrictions, and stuff like that. And essentially, when we are going outside of the Amazon interface, they will charge us standard rates here. So if you think about it, if you use their own service on their own platform, you will get some discounts with respect to the cost model, right? If you go outside their engine, for example, you set up a EC2 instance with Mac OS, right? You pay more. You get that idea, right? That's a business decision. So anyways, so we don't need this description here. I believe most of you are familiar with what MySQL is. If you're not familiar with it, I am assuming that for any database class that you have taken in the past, you have had to work with at least one of these 5 different database engines that was there. Okay, even if we ignore or. So choose the one that you're familiar with and then move forward with what we are working with it. Okay, so here there are some options that says that some of these database engines will not be able to support multi-availability zone DB cluster deployment, right? So that means they cannot set it up for you. So you need to be kind of familiar with respect to that. So for this exercise, this is not our primary goal of setting up the multi-AZ deployment. We will come to it after this, okay? But what you have to pay attention to is which vendor version are you going to work with? So it is always kind of suggested that you choose the highest version that is available. But just a quick fact on these versioning parts of the software packages that we work with. There are 2 different options when it comes to versions, right? So the one which will become the latest version and the one which is the stable version. So my personal experience suggests that working with the stable version is kind of better because you don't face the bugs that comes with the creation of the latest environments as such, right? But again, if you feel adventurous enough, you can always go for the highest version and work with it, right? That problem is not applicable here. MySQL 8.0.32 has been out for some time already, right? So that is not a problem. So here, then you get to choose the option of for what purpose are you deploying your database for. So you can either choose to go directly for a production environment, or are you creating this instance for just development and testing environment? Or for example, what we are doing is just we are understanding how to kind of work with the database as a service. So you can see here when you go to the production environment, this option of fault tolerance, which in the sense is stated in the form of availability and durability. Okay, it doesn't have the resiliency part of it, which is essentially what fault tolerance is, but you get the idea. This is basically for disaster recovery. This is to make sure that your service is basically available, right? And each of these options have a added cost of its own. So that is something that you have to keep in mind. So you can create a multi-AZ database cluster itself. So when we talk about a cluster, so that means we're not looking at a single standby node. You have a bunch of groupings that is there. So it's kind of replicating that disaster recovery behavior, or you can create a single instance of your recovery, okay? Or you just create a single instance, which is kind of not the best suggested way to go about it when you're working with production environment. The same set of options is available in development or testing if you want to test out the database recovery options. As we said, since these options are not available within the free tier, the moment we choose free tier, they kind of get grayed out for us, right? But it doesn't mean that if we choose free tier and we launch this instance right now, we cannot come back to that instance that we had already launched and change these options. We can opt in, okay? So that means we can always upgrade from the free tier option and go up in terms of the offerings by paying, of course, the money that is required for these particular services. But that option is always there. You don't get locked out just because you chose free tier, right? And we are going to do the same thing, is that once we understand, then we will run this multi-AZ database instance and not cluster, okay, to kind of help us understand how to actually set this architecture up, which is kind of quintessential with respect to working with a database recovery setup for our database setting, okay? After that, we will have the option of our database name, and then setting up the root password, and then setting up a password here for your master node, and then confirming that password, right? So here I will need to provide an option here, and this is the option that essentially will be used in order to kind of identify what kind of database that we are working with, okay? So I can give whatever name it is there here. So I can give something like test database -1, Okay, this is the name that I choose to give here. You can choose to give whatever name that you want to give. I will leave the master username as admin itself. Okay. So you can allow AWS to kind of control the management of the user credentials. All right. You can kind of delegate that activity to AWS master. If not, leave this box unchecked. I'm going to leave this box unchecked. Again, as we work with IAM service, if you want to, if you choose to allow AWS to create its own password, then you can check this box. I'm going to leave it empty. And then for the master password, I'm going to set up a very simple password here, admin123, right? So I'm just going to write these three things down because in case I ever need it later on, I just have them available. Okay, so this is basically my instance. And then my root password or root username is basically admin. And I don't have to protect these secrets because essentially once these exercises are done, I'm going to destroy this service and I'm not using any kind of revealing information. So I think I'm okay with this. All right, so this is the password that I have used here. All right, and then you can set these two passwords here. All right, so now it comes to instance configuration where you actually have to choose the actual EC2 instance that will be supporting your database server, right? Some options are grayed out again, and as a result, this is directly due to the fact that we have used a free tier account. So remember, as we discussed, there is the M class, then there is the memory optimized class, which is the R and the X classes, right? You can check the description of these different classes again from the EC2 documentation, okay? But the one that is available to us in the free tier account is basically these T classes, which is the burstable classes. So as and when required, you have peaks of activity, and then otherwise it kind of stays low, so to speak, right? So what we want to select is the most simplest one, okay? So here, the only difference between the T3 micro and the T2 micro is the fact that you get two virtual CPUs instead of one virtual CPU, right? So you can create this or choose the basic one that we have. The T3 micro is also present in the free tier account. So that is the only reason why you were seeing that. You can keep going more than that, but we don't need all of this because we're not going to work with the actual database itself, right? So I'm going to select db.t2.micro. So, okay. So the instance type from EC2, we only add a prefix to it, which is db dot, something like this, okay? And then storage is there. In EC2, we have seen that if you work with a Linux instance, it gives us a basic 8 gigabytes storage volume. Okay, so that is the amount of space that is required to kind of run your operating system. Windows gives us 30 gigabytes because it needs more space and stuff like that. So here, you also get the option to kind of provide how much data or how much volume of storage do you want to start off with, right? So I'm going to stick to the default option that is there. If you want to go above than that, I think please keep in mind that there is a restriction. I do believe you can double check this with respect to the storage that is allocated for RDS. So don't go above 30. That's like the general rule of thumb I follow on free tier accounts, is to not overshoot 30 gigabytes, so to speak, right? And I will stick with the general purpose SSD because I'm not doing anything which requires a custom storage volume and stuff like that, okay? You get with the options of auto scaling. This does not cost us any additional money. It's basically saying that if we run out of it, the space 20 gigs that we have offered, then AWS will essentially take care of the addition of new storage as and when required, okay? So here we are saying that that storage has to come way, way less. So we are never going to hit this volume. So we are just going to leave it as default, whatever option is there, okay? So then comes connectivity. Connectivity is very important because there are some firewalls that will be protecting our EC2 instances and stuff like that. So since we are deploying the service on the EC2 level itself, it is directly associated with our security group policies. Okay, so that is something that you have to be very careful, that you have to allow the traffic of database to go through the security groups. All right. Otherwise, you cannot connect to your database even if you have this identifiers up and running. Okay, so that is what you have to keep in mind. Okay, so a few things to note here is that we have the option here which is do not connect to an EC2 compute resources. So it will say that it is not going to set up a connection to a compute resource for this database. You can manually set up a connection to a compute resource later. Yes, we want to do that. We will do it in the third exercise when we set up a full stack environment. So we're going to leave it as such for now. Okay. But if you want to set up that full stack environment right away when you create the database itself, then essentially you would go for this particular option. Okay. Then you also have to specify what kind of internet traffic are you using, IP addresses you're using. So essentially, we know for a fact that our VPC uses IPv4. So we're going to keep it. If there is a combination of v4 and v6, then you are going to be using this dual stack mode. Okay. Then we need to select the VPC within which this needs to be deployed. So if you have multiple VPCs within a particular region, then make sure that you select the right VPC. We are going to select the default VPC that is available for the Ohio region for ourselves. Okay. We don't have a specific subnet group. So we're just going to leave it as default. Okay. Then we have the options of accessibility. That is, can people from outside be able to ping your database? So this is important. So this is the part where we are saying that if you have resources outside of your security group to be able to connect to this particular instance that we are going to be launching, would you allow that? So you select yes. If not, then you are going to select no in this particular instance, right? So this is based on the specific architecture that you are working with, the system architecture, not the architecture of the database itself, right? So I'm going to leave the public access as no itself because I do not expect anything outside of my Amazon EC2 instances and other resources that is present within the VPC to be able to ping my database. But this is the part where if you want to launch a database service that is on the cloud and you're developing your local program on your local computer, then this needs to be set to yes. Otherwise, you can never connect to your cloud database. Okay, so that is what you have to keep in mind. Then we have to choose an existing security group. So before I connect to this security group, okay, I actually need to make some changes to the security group that we will be working with. So I'm going to go to EC2 dashboard. Okay, so I'm in the EC2 dashboard. Please keep in mind. So if we come here, we are in the Ohio EC2 dashboard. We need to go to security groups. We need to select the security group, our running security group that we have been working with, where we had specified all of the different network traffics. So I need to go inside of that. I need to go to edit inbound rules. Okay. And then I want to add another inbound rule. And this time I am looking for MySQL. Okay. So basically MySQL or Aurora service that supports MySQL, because that's the database engine that I selected. If you chose a different engine, please make sure that you allow for the traffic, because each of these engines are going to run on a different port number. Okay. So we set the port number. MySQL runs on 3306. So that's the port number we have specified. Again, if you chose something else, please make sure that you specify that particular traffic. Okay. Here, I'm just going to set up from anywhere, general. Okay. You can customize it to make it seem as if it belongs to this same security group, then only the communication could be allowed. So you can add some added policy security to it, right? So here I would just say connecting to DB engine. Okay. So I would say RDS database engine for MySQL. Right. So once that is done, I will just save this rule. And this security group is successfully updated. So I will go back to my RDS console, and then I will select my demo SG Ohio security group. Okay. And then I will remove the default. Remember, you can add multiple security groups to a particular instance, I believe up to 5. All right. So availability zone, I'm selecting no preference here. But if you want to kind of decide that, hey, I want to deploy this to a particular subnet, then you can select from the available AZs that are present in that particular region. So let us go ahead and select 2A. So let us try to replicate the architecture that we just discussed in the slide. So we're going to set up the master in 2A, and when we do multi-availability zone, then we will set up the replica, the standby in probably 2B and stuff like that, right? So we don't want to create a proxy. Proxy essentially is some other service that will be able to interact with this particular service that is running. Okay, so we don't have any requirement for that. Certificate authority, you can leave it as default. Okay, you can read what the certificate authority does. So we don't have to worry about that. You can open the additional configuration if you want to run the database on any other port than 3306. Then you can change that. Please keep in mind, if you change this, you need to go back to security group and change that as well. Okay. Then the option is with respect to how you're going to authenticate the database service. We are going to select password authentication because we have set up for that itself. Okay, you can also set up for IAM authentication. Remember, just the way we did the authentication for our S3 service, we can set up the authentication through IAM roles for our database service as well. So that option, I hope that you have not forgotten that you can create IAM roles to allow different AWS services to perform or basically query on your behalf. Okay, so the previous exercise that we did for that is we took an EC2 instance, we gave it some permission that allowed it to communicate with our S3 bucket. So I can very much replace that S3 and put an RDS there, and that will work the same way, right? So we are not going for that. We are going for password authentication, which is kind of a bit straightforward. Okay. If you set up monitoring services, CloudWatch will be associated with this, and that will cost you differently, okay? Because CloudWatch is a separate service that is going to run. And then you can set up your additional configurations. You can set up what kind of database that you're working with, if you want to create a new database and stuff like that. So let us go ahead and give a database name, okay? So remember that everything till now was the environment itself. But within the environment, you have database. Within the database, you have tables. So where do you specify those things? Well, that is the additional configuration here. So I will just say here, cloud-computing database. Okay, I will give this a name, copy this, and then put it in my stuff here. So DB name is this. Okay, so I'm going to provide that. Oh, it does not allow me to put this weird characters. So I'll just turn into this. Okay, this should be fine. Yeah, so it doesn't allow hyphens. So we're just going to remove that. And we're going to paste this here. Okay, parameter group is going to be left default at the 8th version of MySQL that we are working. You can keep this checked for enabled automatic backups. It's up to you. If you want to remove it, then you manually have to take snapshots. If not, then it will take the snapshots by itself. And then it will ask you how many days the backups will be kept. So these are just like creating checkpoints in Windows service, right? So you can kind of manipulate that, how many days you want to keep it. You can remove it if you're working with it. At the end of the exercise, we're going to delete everything. So this really doesn't play a role, but keep in mind that this is an option that you have. All right. And then this is the part where it asks you, when do you want to create the backup? So you can say no preference. And if you have no preference, then AWS decides when it wants to do it. But if you're, let's say, working in a production environment or a development testing environment, then here you can specify a window where the backup can be performed, right? And at that point of time, please note that your database will be out of commission, okay? So this is where you can have some sort of say with respect to backups, all right? Or when the upgrades will be performed and stuff like that. So I will leave it at no preference right now because this has no implications as such. And then you can create a replication in another region altogether. If you want to take it a step beyond multi-availability zone deployment, then what you can do is you can take the replication of the backup, put it in an S3 bucket that runs on an entirely different zone region altogether, not even a zone, right? So if you want to enable this, you can enable this. I'm just going to leave it default as such. How you're going to get your logs? Database logs are pretty important. So these are the different categories of logs that you have. If you select any of these, again, it will go into CloudWatch. So CloudWatch is the monitoring and logging service. So anytime you want monitoring, anytime you want login, you're going to be working with that, right? IAM role, we're not setting it up because we're doing password authentication, so we don't need anything of that. Minor version upgrades, you're allowing for that. I'm going to leave no preference on your maintenance as well, because the same thing happens. You can either choose to do the backup, and then the maintenance is also going to take your database out of commission. So again, I keep it as no preference, but if you're working in a real environment, then you can specify when those maintenances will be applied. If you want to not allow AWS to apply those maintenances, then you can uncheck this option, and then it will kind of take care. And then this last option is very important option. If you check this box, you cannot delete your database. Okay, unless you remove this protection, your database cannot be deleted, whether intentionally or unintentionally, you cannot run it. Okay, so basically you cannot drop the whole database, or that command, which is delete DB name, you cannot run it. It won't be allowed, right? So if you check this box, that is basically the restriction. So I'm not going to check it right now, because if I check this, unless I remove this option, I cannot even delete my database manually from this particular interface. But keep a note somewhere that if you check this box, this is going to provide you protection against any kind of accidental deletion or any kind of malicious deletion. So if somebody, shouldn't happen, but if somebody is somehow able to get to the point where they run the delete database script, right, after dropping the tables, then if this is enabled, then those commands will not even run, right? So keep this in mind. So it gives us an option here on the instance types that we have available on the free tier account. We can run up to 750 hours of that instance. Okay, so that is why the hour is there. We get 20 GB. So, okay, so that is the restriction. It's not 30 GB, and we get up to 20 GB of automated backup that is there. Okay, so that is up to the first 12 months, and then this will change essentially after that. So just hit create database after that, and then this will take some time. And then once it's done, okay, so we are using something from their dictionary, so it doesn't like that. So anyways, not a problem. We don't want to save it. So this will start a EC2 engine using T2 Micro. On top of that, it will implement or basically install a database server with the database engine being MySQL server, okay, version 8.0.32, and set up all of those environments. So this is going to take some time, and we need to wait for it. And once this is done, what we are going to do is basically do the multi-availability zone deployment, which is to create a disaster recovery architecture for our database. And for that, we need to step a little bit outside of our free tier accounts boundaries, and we need to kind of set that thing up. Okay, but we cannot create the replica until we have the master itself. So we need to give it some time. We need to wait. So I'll be pausing the recording at this point of time, and then resuming it once this thing is up and running again. Okay. All right, so we're back with our database service running at this point of time. It's still going through the last stages, but the last stage that it is going, it is performing is basically creating the backup, because we opted for the automated backups. And there we go. Things are available right now. But essentially, you know that your server is live when you start noticing this CPU factor here, which kind of gives you the idea that your database is basically running at this point of time. So for all those who might be waiting, anytime now, if you see backing up or if you see this CPU meter here, then you know your database is live. And then that kind of signifies that your master is running. Okay, so that's the most fundamental level of setting up a database. Okay, so if you now left click on this database identifier here, that will take you to the additional page where you have all of these different options. So pay attention to a few things that you need to be aware of on this particular page. Of course, the summary is not that, it's not, I wouldn't say it's not that important, but if you need any information there, you can get it. But this is where you need to start paying attention. Okay, the first thing is connectivity and security. So if you want to connect any of your programs to this particular database itself, then you have to know the endpoint that you're working with and the port number on top of which your database server is running. Because essentially, when you create your .env variables for your DB connection in your programs, then you need to specify this, right? Because this is the address that will ping your database and connect to it, right? Be familiar with your security groups as well. Your security groups must allow for the database traffic to go in and out. Okay, it's a stateless, I believe. Yeah. So if you allow it, then the outbound will also happen by default. Okay, by the nature of the firewall policies that we're working with. So two things is you need to get right the endpoint connectivity information, you need to set up the firewall properly so your connections go in and out, right? Other than that, there is a replication that is taking place here, but it is in the same zone. It's not following the multi availability zone deployment that is happening. So this is all with respect to connectivity. So once you click that database option, then that is where you will start getting all this information. Monitoring service, by default, you will get some values. If you want to increase the frequency at which you are getting this information, then you need to set it up separately from CloudWatch. But again, that is going to cost you a little bit more, okay? Any kind of logs and events against your database, you will find it in the logs and events sub-tab here. So if anything went wrong, if you're trying to figure out what is happening, this is where you come to. And then you can see here the error log and all of these informations are available here, and you can download it here. And then you can analyze it from there if you're ever looking for logs and stuff like that, okay? Configuration wise, you get all of this information within the configuration tab. So everything that we went through, discussed, I saved a lot of stuff and things like that. But if you don't save it and all those information, then keep in mind you can come to configuration, but I believe that you won't be able to see your password. Yeah, essentially you won't be able to see your password. So this advice I kept giving for my undergrad class for database, and it still keeps happening, is like, don't forget your root passwords. Like some people say that I got locked out of my root. What to do? It's like nothing to do. It's like you redo. That's the only thing you can do, right? So again, please do not forget your passwords, as at least for master that you're setting for your root account. Don't forget these passwords, right? Don't do that, right? The last thing that we have here is with respect to maintenance and backup. So depending on what fields and values you chose for maintenance and backup, you can get all of those information here. I personally, I did not select here when doing this exercise any particular time window. So they chose for me what time window that they are going to be doing. If they are going to be performing any kind of maintenance, they will do it in that time window, okay? Either I can choose that, or I can choose to kind of, specify my own window, and that will take care of it. Tags, there's nothing functional here, but it's important in a production environment that make sure that you give some tags. Okay. Other than that, you have additional options here. So you can see here, if you go to actions at the very top right corner, let us remove this green banner since we know our database is up and up. Okay. So now it gives us the option to convert it into a multi-AZ deployment. Remember, in a production environment, I won't say development environment per se, but it's good to test it out. So in those environments, it is very essential for database recovery that you opt for this multi-AZ deployment. You don't want it to be in the same area, all of your backups, essentially, okay? You can pause it, or as they say, stop it temporarily. You can restart your database server if you want to restart the service. If you want to delete it, this is where you want to delete it from. So remember this area, because once you're done with today's class, working it out, you would want to delete your resources. Essentially, you don't want the compute engine to keep on running and stuff like that. If you want to set up a connection to a different EC2 instance, then you can set it up from here. I'm going to show you probably a more difficult way than what AWS offers, but it's kind of good to have that, because if you're setting it up in a local environment, that is, your program is locally, then that kind of takes you through that process and it creates confidence, right? This is the read replica that we were talking about. That is, if you want to create a replica only for performance purposes, then you can essentially create that read replica. And they have come up with this new blue and green deployment, which kind of cuts down on the downtime that it takes to upgrade or maintain your database and stuff like that. So this will, again, require you to create options. You can create backups by taking a snapshot, okay? And then if you already have a snapshot that is present, then you can restore to a point in time, okay? And then if you want to move the snapshot to a different region or something like that through an S3 bucket, then these are the options. So all of the additional functional options that is there around it, that is given there. If you click on modify, then it will take you to the new instance again. So remember, we talked about the fact that, oh, I started with a T2 micro, I want to change it to something else right now, okay? If you want to do that, you want to scale up, then you go to modify, essentially, and then when you go to modify, then all of these options that we had selected before, it is available to us again, okay? The same sets are available to us. So, oh, I forgot to put a maintenance window. Well, it's okay. There's no problem. You can just hit on modify, come back, go down here, change any of the different things that we specified. Again, back again, right? So these are the options that are available to you. Okay, so let us do the simpler one first of the other two exercises that we have to do, which is to set up the read replica. So if you refresh your memory real quick, essentially we have now set up this master node, okay, on our instance. The next option is to create, for performance purposes, this read replica backup, which is going to work only if a master node is present. And the whole purpose of this is to support additional read requests, but the write options is going to come only to the master. Okay, so in order to set this up, we are going to follow exercise 3 actually. So we're going to skip over exercise 2, which is a multi-AZ deployment. We're going to come back to that, but this is the simpler of the two. Okay, so previously, the way it was being done, as you may note here in your steps itself, on the slides itself, it is to require us to go into the connectivity and security tab and let us see that if we still have that option available here or not. Okay, and then we need to browse down to the section of replication. All right, and then we need to find the replication information, and we already have one ready. No, we don't. Okay, so let us click on that and let us see where it takes us. Okay, so you can see here, this has a required instance. This is the required instance that we worked with, the connection here. So what I am looking for is the fact that this is not replicated. So if I go to settings here, let me go back one level. I'm just messing around with the old interface to see if we get that same option or not. Okay, we don't. I don't see creating the replication information that is there. So we're going to take the new interfaces option. We're going to go to action here, since we have already worked with test database 1. We are going to come here, go to create read replica. Okay, so that is the backup that we are going to be creating for performance perspective. Okay, and let's see if this goes through. Okay, so it will first ask for what is the master node. So we need to specify the master node here. I hope everybody is on this page right now. Remember, it's on the top right corner. There's an action button. In the action button, we are using the create read replica, and currently we're doing exercise 3. And the steps specified there is basically a little bit outdated because they have changed the interface a little bit. Okay, but you can go through there, and if you can find that information, you can go through those steps as well. Okay, so here we need to specify the DB instance identifier. The source of the DB is this. I think the DB instance identifier is the unique key that identifies the DB instance that we are working with. Okay, so here we are going to essentially work with this same database itself. So I'm just going to leave it as test database 1 and see how that goes. Or is it asking for test database 1? Okay, so I'm going to use the same thing. Let me see here, and this is the DB name that we had, and this is the instance name. This is the instance identifier. This is the same as the replica source name. And then we will have the options, the same configuration options as we did for our master node. Okay, and we are going to use the same set of options that we did for our master node as well. That is, I'm going to select the burstable classes. I selected that. I remember this. I selected a T2 micro, so I remember this. It asked me where I would want to deploy my read replica. Now you can see here that I get a region option altogether, right? So if you want to take the read replica and you want to put it somewhere which is closer to your client, which might be in a different region altogether, then you can do it. So let's say if you're running a business and that business one office is in the a good amount of your client base, and let's say it's on the East Coast side, and then a good amount of your client base is on the West Coast side or on the Seattle, Oregon region, right? Then you can take this replica, and if you know that you're not going to get too many write requests from there, right, then you can put the read request or the read replica probably somewhere in Oregon itself, right? So I'm not going to get out of the region, but remember what I'm pointing to the fact is that you have the option to change your regions altogether. Okay, same option, storage, we're going to leave it default, general purpose, 20 gigs of storage. Okay, we'll keep the auto scaling option available here, or you can suppress it. You can do a multi-AZ deployment of the replica itself. Okay, so backup is irrelevant of the replica. If it's a replica, doesn't mean that, oh, you cannot create the backup. You can create the backup, right? So if you want to create a multi-AZ architecture for the replicas itself, then you have that option as well. Okay. Again, connectivity, you make sure that you choose the correct IPv4, the VPC, because we're working with this VPC. If we had changed region, then this VPC could have changed to the default VPC of that particular region. We don't want it to be publicly accessible, but if you're pinging this from outside the VPC network boundary, then you need to make sure that it is publicly accessible. Security group remains the same, okay? Or if you want to change it, you can change it, port number, password authentication, everything else, I'm just going to leave it at default. Please do not check this. If you check this, you cannot delete it, okay? And then just hit create read replica, okay? So this instance already exists, so we need to give it a different identifier. So I'm just going to say 1-replica. It wants us to give it a different name. It doesn't like, even if it creates the same replica. So the only thing I changed is basically, I just added this prefix at the very end to kind of distinguish between the fact that this identifier is a replica and this is this, right? If you want to name it something like database Oregon, you can name it something like that, and you can keep this name as database Ohio or database headquarters in order to distinguish between them, right? Anyways, so this will be created and there will be some modifications that will take place because if you have guessed it already, in order to create a replica, this needs to be first copied and then it needs to be sent here, right? So there will be some modifications that will be applied to this if you have changes to be made that is essentially using the master as a source, right? So please keep that in mind when you're working with this read replica operations, but it's pretty simple with respect to, how you need to set it up. It's only a few clicks, right? Now imagine doing this, writing your own scripts, it's going to take some time, right? Even if you know how to work with it, it will essentially take some time itself, right? So we will wait for this modification to finish and this creation to be done as well. And then we will move on to the last exercise, which is to basically create the multi-AZ deployment. And that is also going to be very straightforward because it's basically a field change. You're not changing any kind of things. All you have to do is you just select multi-AZ deployment, and then you create a standby deployment. So here we created a replica. Instead of creating a replica, we will create a standby. So you cannot ping that particular node unless your master fails, because the address of the identifier, you can see here the identifier for this is different from your master, right? But when you create a replica for backup only, or for disaster recovery only, which is identified by saying, you're creating a multi-AZ deployment, then essentially, I forgot what I was saying. But essentially, what you can do is you just need to click a few buttons and let Amazon handle the rest, right? And it takes care of it for you. So it's pretty cool, right? To have maintenance and provisioning being delegated to a third party, right? And you pay for the service that you're using, okay? They're kind of pushing it on us, this thing, but it's a good option to have. I will check it out sometime. Okay, so did everybody get to this point? Is everybody waiting like me?
Yep.
Okay. Let me see if my database is still active. I don't want to mess with it. Okay, so now I have these clusters that are available from Amazon as well. That is pretty cool. Let us give it a shot and let us see. Just click into that database. You can minimize it if you just want to see the master node. You can maximize it if you want to see the replicas that are there. In connectivity and security, you can see that there are replicas that you have personally created, and the replication source is basically this. And this was the replica that was being shown initially that was created for us. Okay, so what I wanted to do now is basically select my master. Okay, it's doing some modifications and I'm kind of skeptical to push anything into it. So we will wait it out. Probably will take a few more minutes, but we'll wait it out. See what happens. So it's still creating a replica in US East Ohio. The database might take a few minutes to launch. Okay, so it's not in commission right now. So we will wait it out again. So I'll pause the screencast and resume it when we are ready again. Okay, so our master is back in commission right now. Okay, and AWS still is working on creating the replica itself. So you can notice here that even though it has no data, it takes a while, right? We haven't even created any tables within this environment. So you can kind of project and get an idea of like, it is going to take a while if you apply these operations to an existing database, which has a bunch of data. So the last exercise with respect to our database setup is to create the multi-AZ deployment, right? So for the multi-AZ deployment, you need to make sure that you have the master database selected, okay? There are some options of how you can do this multi-AZ deployment. The first option, or the traditional option, is you can go to modify, okay? And then if you go to modify, you need to kind of browse down to the region of availability and durability, where you will find the information for multi-AZ deployment, right? So if you create a standby instance here, which is basically required for production usage, it is actually suggested very hard, right? Very strongly recommended that if you're going for a production environment, this architecture should be used, okay, for safety reasons. This is one of the ways you can set it up. That is, you can go to modify, go to the subsection of availability and durability, and then create a standby instance. Or right now, with the interface, you have another option with the database selected. You can go to options and you can convert your database into a multi-AZ deployment, right? So this is another way where you can, you can see here, it's a new set of interface that they have added, that you can set this up directly from there if you want to go there. So we are going to go into this option and see if we get to the same page essentially. And now we can see our read replica is also almost ready at this point of time, but we are going to hit convert to this. Performance impact will be there because it's going to go over all of our stuff again. And then you are asked whether you want to do it later on when you have the next maintenance window time that you probably should have specified already. If you haven't, then you are basically using the time window that Amazon has set up for you. If you want to avoid all of those stuff, you want to do it right now, okay? Because, well, we don't have any kind of production problems. So we are going to apply immediately. And then we are just going to say, convert to a multi-AZ deployment. And, well, that is done. Okay, that's all you needed to do. You don't need to worry about it. Amazon will take care of this multi-AZ deployment. Essentially, what you need to remember is the architecture that we discussed, is that it will take a replica, put it somewhere else, and that will be the standby node. It will be synchronously replicated. It will have all the information that your master has. And in the off chance your master fails, it will fail over to the standby. The standby node will get all of the connectivity and security information of the master, and then it will continue to behave as if nothing happened. Okay, so that is the failover strategy. So these new interfaces kind of abstracts a lot of information from us with respect to what exactly you should have done, or you should have, the fields that you needed to work with. But this is okay, as long as you conceptually understand that what multi-AZ deployment does that we discussed at the beginning of today's lecture with respect to the architectural diagram, then essentially that is what we are going to be working with. Okay, so the last bit of exercise that is there, the additional exercise, is the WordPress exercise. At this point of time, with a master instance running, the prerequisite for that is that you need to have at least one master database that is running. So you can ignore the multi-AZ deployment, okay? You can ignore the read replica. What I want you all to do is, on your own time, set up a master database, or you can use this, which is already running if you want to do it right now, okay? But don't leave it running for a while. If you want to come back to it later, please destroy it right now and then redo the process later on, okay? It's a pretty straightforward process without much talking, because I'm explaining too much. It will hardly take 10 minutes and then 10 minutes to set up, so to speak. And then all you need to do is, I will walk you through the steps of what needs to happen, is that once this master database is running, you need to go to EC2 environment. You need to go to instances, set up a new Linux instance, okay? And you can drop that Linux instance if you would like to, in order to reduce the pinging time, in the same subnet as that of this particular master, or you can put it in a different subnet. It's not a problem, right? As long as these things belong to the same security group, it's fine, okay? So set up your security group, launch your instance. And once you launch your instance, using the slide that is there, you can SSH into it, or you can run those different commands as user data, whatever you wish to do. But essentially, you need to install WordPress. WordPress is basically a PHP interface to develop your content management sites. Okay, so follow these different commands. Probably the PHP version that is specified on the slides has changed from the last time that we have worked with this. So you might want to choose an older version if it allows you, or you can choose a newer version, which will be safer bet. So find out which PHP version currently is available on that particular instance that you have launched, and then use that. Follow the rest of the commands, okay, to set up the server, install WordPress on that particular server, okay. And then the only thing is you need to configure WordPress with your database instance itself. So follow the next 2 steps. That is what will give you the confidence in order to kind of do a full comprehensive connection of your database with a full stack application or process that is running. And then see if you can kind of get to the point where you have, or where you can essentially see your WordPress front end connected with your backend relational database service that is running. Okay, so I will leave this for you guys to try it out, to check out a Hello World site. This will give you sufficient confidence. If you have any problems or difficulties, please do let me know, and we can work together to kind of clarify that. All right. So in the next class, I would like to start DynamoDB, which is the non-relational database, and walk you through the conceptual background of DynamoDB. Talk a little bit about NoSQL databases, but not as a database class, but was more like how you use it compared to an RDS networking site from a networking perspective. And I'm going to walk you through the setup and how you work with it on the AWS platform itself, right? So once that DynamoDB is done, we can move forward from storage into DevOps, okay? And look at the different DevOps services that are there when working with AWS platform, okay? So I will wrap up here. Again, please remember, once you're done demoing, not demoing, but practicing, destroy all your services or resources that you have launched here. So for me right now, that is with respect to these 2 databases that is running. This is modifying right now because it is creating a standby of this particular master, and we'll launch it somewhere else for disaster recovery purposes. Because if you remember, we just created a multi-AZ deployment. So if you guys created the multi-AZ deployment too, this is all that is running, right? So you cannot physically see that. You cannot physically ping your backup for disaster recovery. You have to keep that in mind. It's always there though. And in case something happens to your master, it's going to take over from there, right? It's going to become the new master, right? So the only visual conceptual affirmation that you can get with respect to a multi-AZ deployment is the architectural diagram that is provided in this slide. So please understand that architectural diagram, because that is what you should have in mind when somebody tells you that, are you using a multi-AZ deployment for disaster recovery? Okay, so with this, I will wrap up today's lecture, and I will take any questions that you may have from the floor. Thank you.
Yeah, I mean, I guess just a quick question myself.